Hello geometry students. Here's your lesson for section 3-2, angles formed by parallel lines and transversals. Missy McCarthy, math instructor at Oak High School. Let's do a quick review or recap over the previous section just to make sure we're familiar with the different kinds of angles. So this says identify each angle pair. So if I look at angle 1 and angle 3, those are what we would call corresponding angles. If I look at angles 3 and angle 6, they're on opposite sides of the transversal. Here's my transversal. I'm going to call it T. Opposite sides, so that means they're alternate something. And then if I look in between these two, they're on the interior, so those are alternate interior angles. All right, we're looking at angles 4 and 5 now, alternate exterior angles. And then lastly, we're looking at angles 6 and 7. They're on the same side of the transversal and they're on the interior. So same side interior angles. All right, so that was just a little warm up to get you ready for dealing with these angles now. By the end of this video, you should be able to use theorems about angle pairs formed by parallel lines and transversals to find the measures of these missing angles. Some of the problems that you solve using the postulates and theorems might involve setting up a system of equations. So you want to be capable of solving a system of equations. Prove these theorems, the alternate interior angles, same side interior angles, and same side exterior, and alternate exterior angle theorems. The word alternate should be in there. Without assistance, and then state the postulate or theorem that allows you to prove that angles are congruent or supplementary. So let's take a look at the one postulate and 3 important theorems in this section. The one postulate in this section, again, which is a statement that cannot be proven, that we just accept as true, is the corresponding angles postulate. And it says if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So here we have 2 parallel lines. We know that they're parallel from the markings on the lines. That's what lets us know that they're parallel. Then T right here is my transversal. So I have 2 parallel lines cut by a transversal. Then what we can automatically assume is that the corresponding angles are congruent. So 1 is congruent to 3. 5 is congruent to 7, 2 is congruent to 4, and 6 is congruent to 8. That only happens if the lines are parallel. So that's the corresponding angles postulate. So we have 2 parallel lines. Line AG is parallel to line DF in this example, and they want us to find each of the measures of the angles. So they want us to find angle ECF, that's this angle right in here. And they want us to find angle DCE. Angle DCE. That's that angle right there. So I need to know the value of X. But first I'm going to look at ECF. So ECF, I only have the corresponding angles postulate. So I'm trying to find the angle that it corresponds with. Because the lines are parallel, I know my corresponding angles are congruent. So that this angle is congruent to this angle because they are corresponding angles. So that means the measure of angle ECF is 70 degrees because it corresponds with angle CBG. Now if I want to find angle DCE, I know that that corresponds with angle ABC, and I know because of the corresponding angles postulate that if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. So those angles are congruent. So that means that 5x has to be equal to 4x plus 22. So that gives me x equals 22. And then if x equals 22, the measure of angle DCE is 5 times 22. So it would be 110 degrees. That would be my final answer there. And that was just using the corresponding angles postulate. If 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So here are the three theorems that we have in this particular section. There's one theorem that deals with alternate interior angles, one that deals with alternate exterior angles, and one that deals with same-side interior angles. The first one says, again, two parallel lines. Notice the parallel markings there. Cut by a transversal. There's my transversal T. Then alternate interior angles are congruent. So 1 is congruent to 3 and 2 is congruent to 4. Alternate exterior angles, two parallel lines cut by a transversal T. Alternate exterior angles are also congruent. 5 is congruent to 7 and 6 is congruent to 8. The last one, two parallel lines cut by a transversal. Then the pairs of same side interior angles are supplementary. So if they're on the same side and on the interior, 1 plus 4 is equal to 180. And 2 plus 3 is equal to 180. So everything else says congruent, but the same side interior angles theorem says it's equal to 180. Notice these are theorems, so that means we should be able to prove them. All right, so we are actually going to prove the alternate interior angles theorem. Given line L is parallel to line M, so I'm going to put my parallel line markings on there. And I get my statements and my reasons. Okay, so here we go. Number 1, L is parallel to M. That is given. Okay, so if L is parallel to M, I know that angle 1 and 3 are congruent to one another. So 2 angles 1 is congruent to angle 3. And I know that by the corresponding angles postulate. Those are corresponding angles. And the corresponding angles postulate says if two parallel lines are cut by a transversal, call that my transversal, then the corresponding angles are congruent. But I also know angle 2 is congruent to angle 1, and I know that because angles 1 and 2 are vertical angles, and we have a theorem that says that vertical angles are congruent. So this is the vertical angles theorem. So now I know that 1 is congruent to 3, and I know 2 is congruent to 1. So I'm going to use the transitive property. If 2 is congruent to 1 and 1 is congruent to 3, then that means that 2 is congruent to 3 by the transitive property of congruence, transpoc, property of congruence, and that's what we were trying to prove, that the alternate interior angles are congruent. So we just proved the alternate interior angles theorem. Alrighty, so find each angle measure. Right now we are looking for angle EDG. Angle EDG, that's this guy right here with the x minus 30. There's a couple things I can do. I know that I have two parallel lines cut by a transversal, so I know my alternate exterior angles are congruent, so I'm going to set x minus 30 equal to 75, add 30 to both sides, and get x is equal to 105 degrees. 105, I'm sorry. So the measure of angle EDG is 105 minus, oh, I didn't even have to do all that. Check this out. These two are congruent. If this one's 75 degrees, then that one has to be 75 degrees. Now, finding x and then plugging it back in, I would have gotten 105 minus 30, whatever that would have happened to be, and I would have gotten that same answer. Okay. Alrighty, so let's see. Angle BDG. BDG. That's this angle right here. And I know that that angle that I just marked, angle BDG, that's this angle right here where the x is. That angle is corresponding, I'm sorry, not corresponding, it's same side interior with this angle. And I have a theorem says if two parallel lines cut by a transversal, then the same side interior angles are supplementary. So I'm going to do x plus 2x minus 135 has to equal 180. So that's 3x minus 135 equals 180. Add 135 to both sides. And we get, let's see, 315, divide both sides by 3, and x turns out to be 105. So if x is 105, that's how big that angle is, 105 degrees, because that angle is x degrees. So I just used here the alternate exterior angles theorem, and I used the same side interior angles theorem for part B. Alrighty, there are those statements. Again, those I can statements. We will practice more of these in class, and yeah, we'll practice more in class. See you then.